polar coordinates. First, we would like to conversion from polar coordinates to rectangular coordinates. How can we do this? We can place the polar system into rectangular system, and then we will have. So here is my pole, here is my polar axis. And if I place this in the coordinate system at the pole at the origin, I'm getting nothing else but the rectangular coordinates. So my point was right here. Let's say that this point has r and theta coordinates, polar coordinates. And now I can connect this. I can connect with the origin, and this is my theta. This is my theta. So I can find the rectangular coordinates. Rectangular coordinates is x and y. So if I draw the right triangle, this is the x distance, this is gonna be my x distance, and this is my y distance. And the distance from the pole to the point, how many times we measure, is my r distance. So using this right triangle, we can find x regarding to r. So what trig functions we can use having x and r? This is adjacent to the angle, right? So adjacent over hypotenuse is my cos theta. Is nothing else but x over r. Now we can solve it for x. So I need to multiply times r, multiply times r. Then r and r cancel out, so on this side I have x is equal to r times cos theta. So we can rewrite that this is my x. In the same fashion I'm finding y. So y is the side opposite to the angle, opposite, and this is my hypotenuse. Opposite and hypotenuse, that it's nothing else but sine theta. Sine theta is y over r. We can solve it for y, multiply times r. R and r cancel out, so I have that y is equal to r times sine theta. And these are my formulae for converting from polar coordinates to rectangular coordinate system. So we can summarize what we've just said. Given r and theta, we can find x and y by using the formulas. X is equal to r times cos theta, and y is equal to r times sine theta. That's the conversion from polar coordinates to rectangular coordinates. Now we would like to convert opposite way. Conversion from rectangular coordinates to polar coordinates. So now we have given x and y, and we need to find it. So if I have given point, let's say that my point P now has coordinates x and y, so I'm asking what is my r, what is my theta, in order to convert this. So the same, we can connect this to this origin and draw this rectangle. So this is my theta, this is my x, y distance, and this is my r. How can I find r having x and y? We can use Pythagorean theorem because this is a right triangle. So we know that r squared is equal to x squared plus y squared. C squared is equal to a squared plus b squared for Pythagorean theorem. So that's the way to find r. And now we need to find angle theta using x and y. So regarding the theta, x is my adjacent, y is opposite. So opposite and adjacent, what trigonometric ratio we can use? It's nothing else but tangent. So tangent theta is opposite, which is y over x. And from this we can find theta. So if I use tangent inverse, theta is gonna be nothing else but tangent inverse of my ratio y over x. And that's how we find rectangular coordinates. That's how we find polar coordinates, because then I can have r and I need to have theta. Polar coordinates is r and theta. So we can summarize this. Given x and theta, we can given x and y, we can find r and theta by using the formulas. R squared is equal to x squared plus y squared, and the other formula is my tangent theta is equal to y over x. Y over x. So those are the two formulae for conversion that we've just learned. This one is for to convert from rectangular to polar coordinates. Polar, we need to have r and theta. All right, so now we will keep using those formulae. We have example 1. Find the rectangular coordinates of each point. So we have the point 3 and pi over 2. We need to find rectangular coordinates, that means x and y. To find x and y, I'm using my formulae for x and y. So we know that x is equal to r cos theta, and that y is equal to r sine theta. And now we can substitute. This is my r, this is my theta. So my x is equal to 3 times cos pi over 2. And my y is equal to 3 times sine pi over 2. So now we need to find this cos pi over 2 and sine pi over 2. Cos pi over 2, we find this from the cos graph. Cos curve has a V shape. At the end is 2 pi, in the middle is pi. What is the value of pi over 2? Here's pi over 2. The value is 0. So we have 3 times 0, which gives me the coordinates of 0. That gives me the value of 0. And now sine curve, this one is cos theta. And sine curve has S shape. This is sine theta. At the end of that S shape we have 2 pi. In the middle is pi. Here is pi over 2. What is the value? How high is my sine? My sine is nothing else but 1. So this value is 3 times 1, which is 3. So this polar coordinates correspond to the rectangular coordinates of x and y, and x is 0 and y is 3. So rectangular coordinates that correspond to the same point is nothing else but 0 and 3. And we can always check that. If I would like to plot this point, so I have the polar pole and the polar axis, and then pi over 2 is right here, and I'm going 1, 2, 3 distances. Here is my point with polar coordinates 3 and pi over 2. Correct? And now in the rectangular coordinates I would like to find the point 0 on the x-axis and 3, 1, 2, 3. So that's the same point, 3 and 0 in rectangular coordinates. That's how you can always check your answer. Now we have example B. Find the rectangular coordinates of each point. So the same story. X is equal to r cos theta and y is equal to r sin theta. So x is equal to 5 times cos 300 and y is equal to 5 times sine 300. So now we need to find the angle 300 angle, or sine 300. We can either punch on calculator, but if they ask for exact value, it might not always work. So how did we find this one? 300. So here is 90 degree, 180 degree, here's 360 degree. So how short we are? We are right here 300 angle. So what is the reference angle? Reference angle between x-axis and the terminal arm. Positive reference angle. So 300 plus how much is 360? 60 degree. So this angle is in quadrant 4. Add sugar to coffee. So only cosine is positive. So cosine 300 is equivalent to cos 60 degree. And positive on this side. So my x is equal to 5 times cos of the reference angle, which is 60 degree. And my sine of 300 is gonna be sine. So this is 5 times sine 60 degree. Sine 60 degree, but in the fourth quadrant only cos is positive, so this one is equivalent to minus. Sine 300 degree is equal to minus sine of 60 degree, because the reference angle is always sine of the reference angle up to the sine plus or minus. So now we need to find the value of sine 60 degree, cos 60 degree and sine 60 degree. We're gonna use our chart. That we can see that cos 60 degree is 1/2. Cosine 60 degree is 1/2. So we have x is equal to 5 times 1/2. 5 times 1/2, 5 over 1. So x is equal to 5 over 2. And now sine 60 degree is root 3 over 2. Sine is root 3 over 2. So we have that y is equal to 5 times minus root 3 over 2. So 5 is like 5 over 1. So y is equal to minus root 3, 5 root 3 minus 5 root 3 over 2. So the rectangular coordinates corresponding to my point is x and y. So it's 5/2 and minus 5 root 3 over 2. One more example, converting polar coordinates to rectangular coordinates. We have -3 and -90. So the same, if we are using the same formula. X is equal to r cos theta and y is equal to r sin theta. That r can be negative, that means the distance in opposite, the point is on the opposite side of the pole. So we have -3 times cos minus 90 degree. And this one is y is equal to -3 times sine minus 90 degree. So we can either use this on the graph, cos graph, cos curve and sine curve, and go to the negative, or use the properties. Okay, cos curve has a V shape. Here is 2 pi, here is in the middle pi, so pi over 2 is right here, and now I'm going to negative 90 degree is pi over 2, right? So this one is 90 degree, so this value is 0. So we have that x is equal minus 3 times 0. Here is the angle minus 90 degree, or minus pi over 2. Okay, this one was cos curve. And now I need to find the sine curve. Sine, we know that it's S shape. At the end is 2 pi, in the middle is pi, so half pi, which is 90 degree right here. And now we can go to the negative direction. Here's gonna be minus pi, in the middle is minus pi over 2, which is minus 90 degree. So the value is nothing else but negative 1. So y is minus 3 times negative 1. So now we calculate those values, that x, now we can calculate those values, that x is equal to 3 times negative 3 times 0 is 0, and y is equal to minus 3 times minus 1. Minus 3 times minus 1 is 3. So the rectangular coordinates is nothing else but 0, x and y, 0 and 3. Example 2, we would like to find polar coordinates of this point. Now we have given rectangular coordinates. So this is my x, this is my y. In that case, this is my x, this is my y. Okay, and we need to find polar coordinates. So we have those two formulae. If we recall, how do we convert this? We draw this triangle, and we have those two formulae, that r squared is equal to x squared plus y squared, and then we have tangent is y over x. We can always draw this, that here's my point P, and this point has x, y, and r, and here's my theta. So now I need to find r and theta. We are looking for r and we are looking for theta to have the polar representation. Okay? So we can go that r squared is equal to I squared is equal to x squared plus y squared. My x is 0, my y is 2, so r squared is equal to 4, so r is equal plus or minus square root of 4, which is plus or minus 2. But 0 and 2 is on the positive side, so my r is 2 positive. And then theta, we are using the ratio, the tangent ratio. So we know that tangent theta is y over x. So my y is 2, so tangent theta is 2 over 0. And this does not exist. So this point is undefined. So for what theta the tangent is undefined? For what theta the tangent is undefined? If we look at the tangent graph, where are the asymptotes? At asymptotes, the theta is undefined, right? The tangent is undefined. So here is pi over 2. Here is pi, here's 3 pi over 2. So my theta is pi over 2. We are looking for theta such that the tangent is not defined. So that's the point where it's asymptote. So at what point the tangent has asymptotes is pi over 2. So the polar coordinates of this point is nothing else but 2 and pi over 2. Polar coordinates have always r and theta. And that should perfectly make sense, because if I would like to draw my polar point, here's my pole, here's my axis, pi over 2 is 90 degrees right here, and I'm taking 1, 2 units is right here. So that's my polar point. And now point with coordinates 0, 2 has 0 on the x-axis, 1, 2, that's exactly the same point. Now we have example B. Find the polar coordinates. Find the polar coordinates of this point, minus 3, 3. So the same story, we can always draw this diagram that represents P to have us connect Y, R, and theta. And we are looking for R and theta, of course, R and theta. So we can see that we can find R using the Pythagorean theorem, that R squared is equal to x squared plus y squared. So those minus 3 and 3 represent x and y. This is my x, this is my y. So R squared is equal to minus 3 squared plus 3 squared. So we have that R squared is equal to 9 plus 9. So R squared is equal to 18. So R is plus or minus root 18. Or we can write that this is plus or minus 9 times 2. We can separate this root. So R is plus or minus 3 root 2. And to choose which one it is, we need to see whether it's plus or negative, we need to see the representation. So we're gonna draw the point. Maybe we can draw it right here. Draw this point. So we have minus 3, which is 1, 2, 3, and minus 3 right here. The point is right here. 1, 2, 3, and 1, 2, 3. Okay, so we need to identify the angle. So if we find the positive angle, then the R is gonna be positive. If we are looking for this angle, then the R is gonna be positive. So let's try to find the angle. Tangent theta is equal to y over x. So tangent theta is equal to 3 over minus 3, which is negative 1. So tangent theta is equal to negative 1. Negative 1 reference angle, we take the reference angle from the chart, where my tangent theta is 1. This is my chart. Reference angle, tangent theta is pi over 4. So theta reference is pi over 4. And now we need to find what quadrant we are. So we have on this add sugar to coffee, and tangent is negative. Tangent is negative. Add sugar to coffee. Tangent is negative in the second and third. So my theta, oh, we draw this point wrong because this point is minus 3, minus 3. So the point should be minus 3 and 3 up right here. Otherwise, we are getting the tangent is positive and it should be negative. So, sorry for that. Minus 3 and 3, the point is right here. And that's where my theta is negative. So I'm looking for this angle. I'm looking for this angle. So this one, reference angle is pi over 4. So we have pi short of pi. We have pi less than pi over 4. Right? Here would be pi, and my reference angle is pi over 4. So pi minus 1/4 pi, or 4 over 4 pi minus 1/4, gives me 3 pi over 4. So my theta is 3 pi over 4. From the tangent is negative in the first and the fourth quadrant, but because we plot that point, we are in the second quadrant, so right here. So my r is gonna be positive 3√2, and my theta is given by this. So polar coordinates of this point is 3√2 and 3 pi over 4. And we have one more example. Find the polar coordinates, the same story. We can draw the diagram if we want to. Diagram is basically to help us see the formulae, nothing else. So this is my theta, and we are looking for r, and we are looking for theta. So r, we can use Pythagorean theorem from this diagram. So r squared is equal to x squared plus y squared. X is minus 2, so r squared is minus 2 squared plus minus 2√3 squared. So my r is equal to squared is equal to 4 plus and minus 2√3 minus 2√3 squared. It's nothing else but minus 2√3 times minus 2√3. So we can go 2 times 2, minus 2 times minus 2 is 4, and √3 times √3. √3 times √3 is nothing else but √3 times 3. It can go underneath. So I have 4√9 is positive 3. So 4 times 3. 4 times 3 is 12. So minus 2√3 squared is nothing else but 12. So we have plus 12. So r squared is 16. So r is plus or minus √16, which is plus or minus 4. And we will have positive 4 because we're going to go in the positive angle. Okay, now connection theta. So we have that tangent theta is y over r. So tangent theta is y is minus 2√3 over, not over r, over x, y over x, opposite over adjacent, over 2, negative 2. Negative 2 and negative 2 cancel out. So we have that tangent theta is √3. Tangent theta is √3. So my theta, we get this from the chart. But we need to be careful what quadrant we are. So from the chart, we are getting the reference angle. Tangent theta is equal to √3 for pi over 3 or 60 degree. pi over 3. But now we need to plot and see in what quadrant, because this is just the reference angle. So if I would like to plot this point, I have minus 2, 1 and 2, and minus 2.3. I'm in this quadrant. So we have add sugar to coffee. So tangent is positive in this part, but we need to find this angle. And we know that my reference angle is right here, pi over 3. So this angle is pi thirds far after pi, right? Because right here is pi. So theta is gonna be pi plus my reference angle, which was pi over 3. Pi in terms of thirds is 3 over 3. This is 3 over 3 pi plus 1/3 pi. So that gives me 4/3 pi. We are in this third quadrant from the point, plotting the point, and tangent is positive in first or third. So it can be either this angle or this. So my theta is 4 pi over 3. Theta is 4 pi over 3. So then my radius is 4, and theta is 4 pi over 3. Then polar coordinates of this point is 4 and 4 pi over 3.